Each year, Microsoft Research hosts hundreds of influential speakers from around the world, including leading scientists, renowned experts in technology, book authors, and leading academics, and makes videos of these lectures freely available.
So as Don mentioned, I've been involved with the F-Sharp Software Foundation. I'll say a few things about that, and one of the activities as part of the foundation has been around data science, and I'm sure everyone here has seen some talk on F-Sharp Type Providers, which was sort of one of the inspirations. If you haven't, don't worry, I'll show it anyway because it's really nice. But it's been one of the sort of inspirations for making F-Sharp better for data science in general. So let me just start with, I think I have two boring intro slides. One is on the F-Sharp Software Foundation. So the idea here is that F-Sharp as a language really has large number of contributors. There's large number of interested parties. One is Microsoft product groups who are building the Visual Studio tooling for F-Sharp. There's Microsoft Research doing F-Sharp related research and the language design. But there's also companies like Xamarin, and they're building tools for mobile development on Android and iPhone. And they've been building lots of the open source tools for F-Sharp, running F-Sharp on Mono. There's quite a large number of consulting companies around F-Sharp who also sort of contribute and are part of the community. There's companies like Blue Mountain Capital, which is a hedge fund in New York, and they're using F-Sharp to do some of their analytics, and they actually built some of the libraries that I'll be using and showing today. So really the idea of the foundation is to bring all these different people from both industry, research, and from the open source community, bring them together and give them a way to collaborate and to sort of own the environment in some way. So if you haven't seen fsharp.org, then please go there. If you find something interesting, you can join the foundation. You can send us feedback. And I think it's really a nice example of collaboration between industry, research, and the open source community as well. So that's one intro. In F-Sharp specifically, I think that the community is really amazing thing. In the F-Sharp world, or I come from my background used to be C#, and I was Microsoft MVP for C#. And when you didn't like something about C#, you would complain to Microsoft, and they wouldn't do anything. In F#, there's really a different approach where if you don't like something, you just fix it, because the community has all the power. F# is open source. There's lots of people helping it and building it and making it better. And we have really good connections with the Visual Studio product team as well, and they actually listen to you. So I think the fact that F# has very active, very lively community is quite a unique thing. And this is just a picture of some of the F# user groups around the world. I actually visited roughly half of them in the US in the last month. But there's so many active people who are actually interested in contributing. And one of the sort of things we've been doing throughout all this data science work is actually engaging with everyone who wants or can contribute. So there's surprisingly active and great bunch of people in Minsk in Belarus. And it's just amazing to see so many people who actually care and want to help, want to contribute. So that's the intro. And what I want to do in this talk is that I want to do sort of two parts. In one part, I'll just show you a couple of examples. I'll do some live coding, which will obviously break because it's live coding, but I think it's more fun that way. So I'll go through 2 examples, and then I'll sort of say a few things in general and leave hopefully lots of room for questions. So what I want to show in the demos is this sort of 3-step cycle, which I think is really important to data science. We always start by getting some data, so that's going to be, in both of the samples we'll start by getting some data, and this is where F# type providers really give you a lot of power, because you can access external data sources directly from your programming language. The next bit is doing some analysis, so once you have the data, you need some way of interactively exploring the data, joining multiple data sources, doing some quick analysis to see if there's anything interesting. And when you find something, you need some way of visualize the results, either by building charts or by producing reports. So, and then you will usually go back and get some more data and learn from what you did before. So I'll go through this loop in 2 examples. And my first example is going to be looking at the US government debt. So the idea is we'll use one source to get the debt as a percentage of GDP, so that it makes sense to compare it over the longer time span. And we'll join it with another data source that gives us the access to the list of US presidents. And I'm going to start, I'll just show you how you would start in Visual Studio, and then I'll switch to a version where I already have some samples. But if you have Visual Studio, then really all I need to do is to create a new F# project. I'm using this tutorial project, which doesn't give you anything. It's just an empty project with a script file. And to do data analytics, I'm going to use a single package. So here I can reference a NuGet package. And assuming I'm on the internet, I should be able to reference FsLab, which shows here. And this is a single package that actually doesn't contain anything in itself, but it references all the other packages that I'm going to be using, and it adds some wrappers to nicely link them together. So this is all I need to start. And once I do that, I can start typing in my F# script file. Is this big enough? Can you see the text? And here I'm just going to reference or load a single script, which loads all the things I need from my package, and it asks about some security questions, which I'll ignore for now. So this is how you get started, and then from the rest, I'll just switch to another project where I already created this, and I added a few more things, but I have really just added some open namespace statements to get things loaded. And I can select the code and run it in F# Interactive. So it's really different to building projects, because here I have some code in my editor, and I run it interactively in the window on the right, and that will evaluate whatever I typed here. So the first step is that I want to use some CSV file, which is here. It's just an ordinary CSV file with a number of columns and depth data for the last 100 years. How many people have seen the CSV Type Provider already? A few. So what I'm doing here is that this is telling F# use the CSV Type Provider which is defined in the F# data library, one of the libraries I referenced. And I'm telling the CSV Type Provider to use this file, the sample CSV file, use it as a sample, and give me a type which I'm calling depth. And the depth type will be generated based on the example. So I'll show you what this does in a second. This part is really only at the sort of type level, because here I'm saying create a type called depth. And this is why I was getting the security warnings before, because this is actually running code in the background in my editor. And when I run the second line, this is sort of runtime part where I'm actually loading the file. And here I'm using getSample to load the file that I used as a sample, but I could load any other file as long as it has the same schema. So what I can do now is to look at the rows. And I can iterate over all the rows. And the interesting thing is happening here. When I do dot on the row, I actually get a completion list with all the column names from the sample. So here, this is where the type provider magic is happening, because it just figured out that there are these columns. And it also figured out that year is an int, because there's only integers in the sample. But the depth, for example, that's a decimal, because there's decimal values. So what I'm going to do here is that I'll create 2 time series. And here, now I'm using another library, a library called Deedle, which is sort of interactive data analytics, kind of like R data frames, which was built at Blue Mountain Capital. And this loads the data in a nice time series, which I can see in the F# interactive. So you immediately get some feedback and see what kind of data we've got. I can do the same for the GDP. So if I select GDP, is that the GDP? Yes, that's the GDP I wanted. Now I've got 2 time series data. And what I want to do next is to join them and create a data frame which will contain these two information as 2 columns. Question?
The equals greater than operator. Is that a standard operator?
No, this is not a standard operator. That comes from the Deedle library. And it's really just saying, sort of map this key to a value. So it's like key value pair mapping.
So it makes a map. Oh, but this is a series thingy.
So the series thingy, so for the F# experts, this is really just creating a tuple. And series is a function that takes sequence of keys and values and creates a series which has 2 type parameters, key and the value. So here, depth is a series where the key is int and the values are decimals. So it's mapping from keys like years to values, in this case just numbers. But it's generic, and at Blue Mountain they use it for financial data where they have keys as date-time offsets, and the values are floats. But you can map from strings like country names to values as well. So I wanted to create a frame, and this is going to be another expression here. So frame takes a list of mappings from column names to columns. If I want to create depth, then I can just create depth, and GDP is going to be mapping to GDP. So this is not surprising. This is not particularly interesting. It just aligns the two series. There's more clever things happening if they had different sets of keys, because that's where you can often make mistakes, and that would align them by the key. You'll see that in a second. I could really just load the CSV file directly into a frame, but I wanted to start with the CSV Type Provider. So now that I've got a frame, I can do various calculations or read the data back. And I'm just going to read the series back first and show you a line chart showing how the depth has been changing. So there's one interesting thing. I can just pass series to a charting library, and that's where the FsLab integration is helping me. So this is the US government debt as a relative to the GDP and the change over the last 100 years. One thing I can do is that I just downloaded the CSV file from some random website on the internet, so maybe I don't really trust it. One thing I can do here is to, sorry, I think I kicked something under the table. What does this do? Huh. There's like a machine with lots of numbers. And I don't know. Aha, that's it. Number 3. Okay. Sorry about that. So what I want to do now is to sort of do some verification that the data I've got is correct, get data from some other source, and do some basic sanity check. So I'm going to use another type provider here, and that's the WorldBank type provider. And what this gives you is access to the data collected by the WorldBank. That's an international organization that collects lots of indicators about countries. And they don't really have the depth data that I need, but they do have GDP. So I can at least check that one of the columns from the CSV file matches to what more trustworthy organization has. And this is, again, a type provider. So here, when I look at countries, it gives me access to all the countries in the world. And this is actually connecting to the internet to get the countries. So Scotland isn't there yet, but if they decide to split, I can program against Scotland without recompiling the WorldBank type provider. Currently, I only want United States. And here, I've got access to indicators. This is, again, getting the current list of all the indicators that the WorldBank knows. The UI in Visual Studio doesn't handle this all that well. I need some search button here. But the thing I want is GDP in current US dollars. And this gives me the data. And I can turn it into a series using the series function. And now I've got data in a time series from another data source. And you can see that this spans from 1960 to 2012. So it's a different range. You can also see that the numbers are different. That's just because they published the data in single dollars. If I want it in billions, which is what the CSV file uses, I can apply calculation to the entire series. And then the last thing I want to do is to join the data. So I can just add it as a new column and say GDP from WorldBank and assign this, mutate the frame, and add it there. And you can see I've got missing values at the beginning, which is because the frame automatically aligned the series and filled the rest with missing values. So this is how you can easily get multiple data sources and join them together. Now, the next thing I wanted to do is to do check if my data actually makes sense. So I'm going to create a chart with the GDP from the CSV file and a chart from the WorldBank and combine the two in a single area. And you can see the alignment working. There is actually a difference. I could spend more time calculating how big the difference is, depending on whether I care. I think it looks roughly similar. So just for the purpose of the demo, I'm going to say that I'm happy with this. But you can see how easy it is to get multiple data and sort of have some verification for what you're doing. And really large part of this is that I can do this all live, typing the code, seeing the results immediately. So this is the first step, and I've got one of my data sources, which is the depth data, and I want to join this with another data set with information on who was the US president. I could probably go to Wikipedia and just type it all, copy it all line by line. There's not that many of them. But luckily, you don't have to do this with F# because we have type providers for lots of things. There's actually a type provider that can extract data from tables, from HTML tables. So that would work with Wikipedia. Here, I'm going to use a different one, which is the Freebase type provider. And what this does is that Freebase is online knowledge graph database, which has lots of different information. I think it mostly corresponds to what you can automatically extract from Wikipedia. And when I look at what they have, I get, again, a completion list. So I can go to sports. There's, I think they actually call football soccer. But there's like World Cups, if I wanted to find who won the last one. You can waste lots of time with this. So I'm just going to follow my plan, which was to go to society, government, and there's a list of US presidents. And this gives me a sequence of values, so I can just take the first one, and this is sorted alphabetically, I think, or in some random order. So I'll get Abraham Lincoln, and once I have that value, I can, again, look at all the interesting things. For example, Abraham Lincoln was born in Hodgenville. There's also a list of parties that he was member of. So if I look at all the parties and print the party names, then you can see he was a member of the Republican Party, National Union Party, Whig Party, and the Illinois Republican Party. So you can explore the data really easily from your sort of code first editor view. And here, so what I need to do now is to get the presidents over the last 100 years and extract their start and end year and their membership. I'm actually going to cheat here and copy some bits of code. So this one, the query curly brackets, that's actually an interesting thing because it uses some F# metaprogramming techniques to take the expression I wrote inside the curly brackets, which says iterate over the presidents, sort them by the president number, and skip the first 23. And it will translate this to some query that gets sent to the Freebase, and it's actually executed on the server rather than running this locally. There's quite a few other type providers that do this. There's the type provider for the Hadoop Hive which can translate your F# code to Hive queries. So this will give me some collection of the president objects. And this is really the only sort of long piece of code that I have to show you. What it's doing here is that we take, for all the presidents, we iterate over all their governmental positions. If that was, if the basic title is president, so we are basically iterating over all the presidents. We get their start year and the end year. If that's null, we'll just fill in some default, which when I was writing this, as you can see, it was in 2013. You can sort of write the code and tweak it as you go. So we get the years, and then we get their membership, whether they were members of the Democratic or Republican Party. So let me run this, and we'll see what we get. I got the results as a F# list or collection of tuples, and I can easily turn this. It's just another data source that I can really easily turn into a frame. So I'll take the terms data, and here what I'm doing is to say, turn this into a data frame, which will turn it into a mapping from ordinal index to multiple different columns. And by default, this doesn't actually know how I called my columns. So you get the item 1, item 2, item 3. Once I have it in the frame format, I can just say, rename the column indices to president, start, and party. So this is the data I've got from the freebase. I think there might be a bug, because when I'm checking, here I'm really just checking if they were Democrats, and then I say they were Democrats. But there's, who was it? I think there's one president who sort of switched parties, which confuses this very simple extraction. I'm not actually looking at their membership during their presidential term. But if no one's complaining, then I'll just use this. If you see a bug, then shout and complain. All right. So what we've got now is that I have my presidents. That's one frame. And I've got another frame, which I called gov, which has the government spending data. And what I need to do to actually display this is to join the two data sets. And that's one of the things that you can do with the DEAL frames. So what I want to do is to use the join operation. And there's quite a lot of different ways for joining the data. The library I'm using works pretty well for financial data sets, as well as sort of lots of others. But for the finance, you often work with time series. So there's lots of ways of aligning interesting time series. If I do it just by calling join, then I don't get anything useful, because what happened is that my presidents are still indexed by just an ordinal number. So that's different index than the years. So to join them, I actually need to first reindex the presidents. And what I'm going to do is to say, index the rows by start. And now I just transform the data set so that the key is the starting year. Now I can join them, and it should be giving me more useful data. So for every year, I've got the depth, and I have a president for every year when the president started, at the start of their term. I actually want to have that propagated for all the subsequent years. So that's one of the things I can do here. If I say this is a left join, that's what I'm doing. But then there's option to say a lookup, and that's basically what to do when there's missing value. So I can say exact or smaller, which means there we go. Propagate the previous value to fill all the subsequent missings. So now I've joined the data, and I can do some charting. I'm actually going to be using another charting library, which is more of a prototype, but it works nicely for this sample. So what I'm going to say, I want to plot the depth, and this is HTML based, so it will just open a default web browser with the data. This wasn't all that interesting, but I can also say use another column as the color. Let's see, and now I've got colored chunks that represent different presidents. Or I can use the party. So this is where it gets more political. I can color them by party. I don't want to spend too much time on this, so I'm not going to calculate who's better. But you can see, you could easily do that as the next step. So what I was using here is a bunch of F# libraries. One was F# data, which is a collection of all the type providers for CSV files, WorldBank, and Freebase. I was using the DDL time series alignment and the data transformation features. I was also using a number of charting libraries. And the last bit I used was this FsLab package, which gives me a really easy way to reference everything just by referencing one package. So that was one sample. And I want to go through one more, which is going to be slightly easier for me on the coding side, but will show some more other interesting aspects. So what I'm going to do in the second example is to look at different information about countries in the world, starting from the WorldBank type provider. And I'm going to close this. I'll probably just restart F# Interactive in case I broke something. And I have a separate project. And this one is actually using a template which you can find in the online templates in Visual Studio called FsLab Journal. And you'll see what it does in a minute. But we start with pretty much the same thing, just reference the packages. And what I want to do here is to use the WorldBank to compare a population of different countries. So I'll get the WorldBank data connection. And here I'm actually I'm interested in all the countries. So I'm iterating over all the countries in the world. And for every country, I'll return a mapping from the name to population in the year 2000. And I'll turn this into a series, and this will run for some time, and then it will give me the population. I'll do the same thing in the year 2000. So now I've got two series. This returns data in individuals. So again, I can do some transformations like divided by million to get the population in millions, or round this. And all of these operations just work on the whole series. So it's really making the calculation over a time series easier. Here it's not actually a time series because my keys are the country names. So I can not just work with year to something, but work with country to something. And that will align the data by the keys as well. So I want to create a frame which has this as population in the year 2000. And I'll add another thing, which is population in the year 2000. And I'll call this... Ah, thank you. I'm trying to cheat, but didn't work. So now I've got the two columns aligned. And one thing I can do here, I'm going to be using another charting library, just one more, which is actually a wrapper for the Google charts, if I'm allowed to say that. And they have this interesting thing where I can say, create a population chart for the year 2000. And you can see the obvious suspected results. There's a lot of people living in China and in India. But again, it's really sort of easy to get the data and see some visual results. More interesting information is to actually calculate the difference. So where has the population been growing the most? Which I can do just by taking basically subtracting the two time series. So now I've got the population growth. And if I want this as a percentage, I can do some more calculations and see what my results are. So now I've got a series with population growth. There's some missing values which I get because I have some division by 0. I could get rid of that, but that's fine. And I can add it as another indicator to my data frame and display that. So now we are getting more interesting data because here you can see that the countries where the population has been growing the most are actually quite different from the countries where there's a great population already. So for example, Mongolia has 33% more than 10 years ago. So that's getting one data here. The other thing I wanted to do is to add some more indicators, such as GDP. So again, I'm going to iterate over all the countries and add different indicators, like GDP in US dollars. I'm mainly using the year 2000 because that's where the World Bank actually has the data for most of the countries. It still has some missing data, which is handled nicely. And when you're calculating over the whole series, it actually handles the missing data as well. So we've got some more indicators. And I'm actually going to copy over a bit of code that adds some other indicators. And let me see what we've got. So we've got, again, a data frame which has a number of columns with different attributes. And the data acquisition is really easy with the type providers. But there's another thing that I can do with type providers, which is less about getting the data in, but more about interoperating with other environments. So in F#, we've got quite a few libraries for doing the data analytics, but we are never really going to be able to re-implement everything. And that's where I can use Type Provider to integrate with R. So how many people here know R or have heard of R? Pretty much everyone. R isn't the pirate programming language. R, it's actually for statistics. And what we've got here is our Type Provider, which uses my local installation of R, and it gives me access to all the packages that are installed on my machine. You can even call the install packages command from F# because it's just a function. But here, there's like ggplot for visualization, lots of other things. I don't really know that much about R, so I'm just going to use basic graphics. But the nice thing here is that I can now see all the R functions that are available, and I can call functions like plot and give it the data that I created on the F# side. And this will actually magically convert the F# data frame into an R data frame, pass it to R, and display it using the plot function. So this window comes from the actual R runtime. And I'm not a statistician, so I'm not going to make any bold claims. Looks like the population in the 2000 is correlated with the population in 2010. That was kind of expected. For all the other indicators, yeah, maybe, I don't know. But the key idea here is really you can access all the statistical packages that people have been writing over the last lots of years. R has like 5,000 different packages, and this mechanism gives you really nice integration between F# and all the R libraries. And there's the integration is really smooth because it will automatically serialize or convert the data. It does it in a kind of lazy way, so it's not doing it all the time. It does it only when it actually has to. So there's one more thing that I actually wanted to show you about this template, which is that so far I was doing it just as an F# interactive script. And I was just typing some code in there. And when I'm happy with the results, what I can do is that I can turn it into a report. And to do that, I can use these special comments with double or triple stars as just a way to hijack the normal F# language to insert some special things in there. And I can write some comments using the markdown formatting. So here this means a heading. It's kind of readable text-based format, so it's useful even if you're doing it just for yourself. So here I said, here's a snippet that does something. I can include other commands like this include value, which says in my report, I want to include whatever this data is. What do I want to do next? We want to say now we can display the population. And I'm just going to copy some more commands. This says the output of this snippet is called GO1, and I'm going to include it. Or we can add some more comments saying this is how we calculate and display the growth. And then we have another section on understanding the indicators. And I think this is the last bit I need. So you can basically annotate your analysis with useful commands, which are useful even if you just don't use it for anything else. But then I can run this project, and what it will do is that it will use F# compiler service, which is open sort of version of the F# compiler that you can call from your libraries. And the compiler service goes over your script, and it formats all the headings, all the HTML. It includes the code snippets. It will actually even give you types of things. This is just generated JavaScript thing. It inserts the data frames as nicely formatted tables. It will insert the Google charts because this is just HTML based. So we can see it here. And it even includes the R chart, which is tricky because R is just a C API that we are calling. All right, so that was the second bit. And here I was, again, using the D library as a sort of integration point. I was using the Google Charts wrapper, which, following the good tradition of prefixing every name with F, we call Google Charts. I was using the R-Type provider to get access to 5,000 tested packages, and I was using this template for generating reports. It can actually generate PDF reports as well. So to say a few words in summary, I think F# for data science is really sort of easy sell because you have all the three parts of the acquire, analyze, and visualize. F# is super strong at acquiring with the type providers. There's good libraries like DDL, R-Type provider. There's some work on adding more machine learning libraries like decision trees. On the analysis part, the visualization, that still needs some work, but that's actually where the F# community is super active these days. So we are sort of working together on making that even better. The fact that you can use F# interactively, type some code, see what it does, I think that's absolutely crucial for doing data science. But at the same time, in F# you end up with .NET code that's fairly robust, and you can sort of start from the prototype phase and go to production quality code just as a continuous process rather than starting in, say, MATLAB and then passing your code to some C++ developer who will spend 2 months rewriting that in C++ so that they can actually deploy it. That's an actual story, and you can find more on the F#org website. So there's a couple of words about how we are actually building this. I think this is really sort of interesting learning points here. But it was open source. Most of the projects start as open source from the beginning, and pretty much all of them use lots of tools that were built by the community. They're all hosted on GitHub. They have actually really nice documentation, which is using one of the tools. So being open from the start, I think, really helps to engage people and get their interest. The other thing is having a permissive license. So all the libraries I was using are either Apache licensed or they're using the BSD license, which means that everyone can just do anything, use them for commercial purposes. I think this is really, again, important if you want to get companies interested in it. They either have to have a way of buying it or they just need to be able to use it. And that's one thing that is really great about the Blue Mountain Capital people, because they actually built lots of things internally and they release it, letting others actually use it. And the other thing is really sort of being engaged and being part of the wider community. That's been super important because all of the projects I was showing have larger number of contributors, both from companies that are actually interested and from the open source community. So this is one of the things that we've been doing under the F# Foundation umbrella, is to have this working group of people interested in data science and machine learning that are actually actively contributing to these projects. And when there's an interesting project that sort of fits the aims, has a usable license, then we can just include it in the tools. The idea with the FsLab package is to pretty much include anything that you might want to use. So if you're sort of in that area and you want to talk more, then I'm around the whole day, and I'm from Cambridge, and I'm actually doing sort of 1 day a week at Microsoft Research here. So just drop me a note and we can chat. Thanks.
Thanks so much, Thomas, for your talk. I don't know if that's working. I'd like to make a couple of comments. One thing I'd like to do is think about this as sort of a starting point, and then just tie in any of your favorite computer science concerns about verification of data science programmability, or scalability of this kind of work. Obviously, this is all running on the local machine. You can easily imagine what happens if we try and distribute and scale, starting with this kind of programming model. Pick your favorite project in Thur.net or Tabular or many of the others, and how can you make it as elegant and smooth as Thomas has obviously put a huge amount of effort into making things, complicated things, simple, and how can you fit those things into this kind of world. From the Microsoft product perspective as well, I think it's interesting. What does it mean to integrate Azure ML as a cloud-based service that you might integrate into this kind of workflow smoothly? Just insert some massive scalable calculation on a cloud service, which we could in some sense make money from as a company. So programming models like this are just a starting point to hook in the many different things we do at a research lab like this and many other people are doing around the world. So with that comment, you want to say something?
Yeah.
You take questions?
Yeah, I haven't actually sort of talked about this from the research perspective. I just wanted to show you how the whole experience actually looks. So that's why most of my time was spent just coding and actually showing it. I think there's a bunch of interesting research questions, including making it more type safe. The other thing I'm actually really interested in is just understanding how live coding works in general, because people doing data science have really different process than people writing software. There's a colleague in the computer lab who does live music coding. I think that's actually a lot more inspiring for this kind of work. So that's just a bunch of ideas.
Okay, so let's take questions now. Who's up first? Anyone?
Well, this is just a comment. I'd love to talk to you guys more about using F# to drive Azure ML, because the experiments in Azure ML essentially are functional programs. They've got this kind of graphical UI for assembling them, but it'd be really cool if we could program them directly from F#.
Cool. Yeah, we should definitely chat.
How much have you done on MATLAB type providers?
Oh, there is a MATLAB type provider. It's in a more sort of prototype phase than the R-type provider. The company who did it, they don't actually need it at the moment. So it's actually on GitHub, but before we can actually put it in there, it needs some more love. So that's a great opportunity for contributions.
Completely showing my ignorance here, but how hard is it to write a type provider if you're sitting on a kind of data, say chemical or biological data?
I think it does require some F# skill. It's not the most obvious thing you can do in F#. It's not as hard as people sort of sometimes say it is. I guess there's part of it is that you don't actually need that all that often. There's lots of interesting data sources that would be great fit for type provider. But we have things like the JSON type provider, which is kind of like the CSV one, where you pass it sample JSON, and that actually works for lots of cases where it gives you an easy way to access anything that has JSON endpoint. I think maybe Don's doing some work with a couple of his interns here to make it easier. So.
Well, and the F# community are doing a lot of work to make writing type providers easier. But I think the general thing is it's better to get the data into a standard format like CSV or into a database system or JSON data or something like that. And so what we really look for are these very widespread common formats which have a sufficient schema or inferable schema to drive the kind of experience you've been seeing here. And then to have type providers for those which sort of gradually bring in more and more of the world of data through this kind of mechanism. If you have good ideas for type provider projects, often the way to get them to go through the system is to find one or two other collaborators. Like if it would only take 2 or 3 people on the MATLAB type provider with a vision for how it needs to work, to kind of crank through that process of really polishing the experience and making it simple and making it robust. And then because it is open source, it's just amazing how people can collaborate on these things to really polish it for all the corner cases that occur. For instance, even when you're working with CSV data, there's so many different kind of corner cases in CSV files. And by making that a collaborative process for where the people who are using the providers can add in that little bell and whistle where you have tabs separating or something like that, or some other things that are needed to really make those things extremely broad spectrum and useful. So that's the sort of process that's going on in the community.
And the F# community has a secret weapon, which is a guy called Gustavo Guerra, who actually works in some other part of Microsoft.
He works in Microsoft being in London.
But he's basically whenever someone puts an F# project on GitHub, he will fix it. And it's just amazing how many improvements he made to the F# data library that I was using.
For example, he's gone through the process of making it usable on mobile development, on Xamarin, Android development.
Actually works on Windows Phone as well.
So broad spectrum deployment, which is quite hard if you're doing sort of compile-time metaprogramming as well. Okay, another question?
It's a really compelling picture you've sort of presented. I suppose, to my mind, the other thing about data science as opposed to maybe just statistics is that it tends to have like a high-performance computing aspect, even the size of the data set or the numerical methods that have been applied to the data set or something like that. I was wondering if you could say something about that. Is that something you've thought about or worked with yet? Or?
It's something that the F# sort of data science and machine learning working group has been definitely looking into. There's a couple of steps in that direction. There's the Hadoop Hive type provider, which is one thing. We've been actually doing some work with Blue Mountain on making the data frame work over data sets that don't fit into memory by having like a virtualized view. I think there's definitely a lot more that could be done on integrating other projects. I think the Microsoft Research Lab in Silicon Valley has a bunch of interesting things like the NIAD project, which is like big compute that updates on the fly. So finding a way of integrating more of these into the F# ecosystem through some form is definitely an interesting thing. I think one of the things that people have been talking about is building something for accessing Spark, which is a Scala-based, I don't really know that much about it, Scala-based big compute thing. But if you have other sort of projects that you think would fit, then definitely let us know. If you're interested in joining this, it's like a mailing list that's not entirely public because we just don't want random questions there. But it's if you just drop me an email, I can hook you up with the organizer of this, and you can be on the mailing list and help us shape it.
Okay, so we're out of time, and so thanks Thomas once again. And as I mentioned in the email, Thomas is consulting with us for the remainder of the financial year, about 1 day a week. So you can grab him anytime. He's also a PhD student at the University of Cambridge, and so you can always find him online as well any time of the day on that. Okay.
Well, mostly at night.
Right, thank you.